Hi, my name is Sahan Karimi, and I'm AMO's engineer working on the frequency performance payments reform. This video is part of a series that AMO has produced to help stakeholders understand the FPP reform. Each video focuses on a different aspect of the new arrangements. In this recording, I'll be explaining the performance calculation. The information I'll be presenting is intended for a broad stakeholder audience and is an overview only. We recommend that participants should read the Frequency Contribution Factors Procedure, or FCFP, to understand more details. In the FPP process, the performance of each unit for a 5-minute trading interval is calculated using its deviations and the frequency measure, or FM, in that region. The performance of a unit quantifies how much the unit contributes to the frequency control of the power system. This contribution would either be helpful or unhelpful, which is shown by the sign of the performance value. A positive sign shows helpful frequency response, while a negative one shows the opposite. For a unit, AMO calculates two performance values at each 5-minute trading interval. One for when there's a need to raise the frequency, which we call raise performance. The other one for when there's a need to lower the frequency, which we call lower performance. As mentioned, performance is basically calculated based on the frequency measure and the unit deviation. We initially calculate the raise and lower performance of each unit at a 4-second resolution. We use these equations to determine the raise and lower performances. For the raise performance, we multiply the unit deviation by the positive FM values. So when there's a negative FM, the raise performance would be 0. For the lower performance, we multiply the unit deviation by the negative FM values. So when there's a positive FM, lower performance is 0. Let's look at an example. In the first row, frequency measure is positive, and the deviation is positive. So we have positive raise performance and 0 lower performance. In the second case, still frequency measure is positive, so lower performance would still be 0. However, because the deviation is negative, the raise performance is negative. In the third case, frequency measure is negative, so raise performance is 0. However, lower performance would be non-zero. Because the deviation is positive, the lower performance would be negative. In the fourth case, the frequency measure is negative, so raise performance would be 0. And because deviation is negative, lower performance would be positive. As you can see, raise performance has non-zero values only when frequency measure is higher than 0. And when frequency measure is negative, the raise performance would be 0. Also, a positive performance, whether it's raise or lower, means the unit helped the frequency control, while a negative performance means the opposite. Finally, in each 5-minute trading interval, we sum up all the 4-second raise and lower performance values to determine the raise and lower performance of the unit over the trading interval. In this example, the sum of all 75 4-second raise performances is positive, which means the unit overall provided a helpful response when there was a need to raise the frequency. However, the sum of lower performances is negative, which indicates the response of the unit was unhelpful when there was a need to lower the frequency. Let's have a look at the visual example of this calculation for 8 trading intervals. This figure is showing the unit deviation and the frequency measure, which are the input to the performance calculation. If we multiply the deviation by the frequency measure when the frequency measure is positive, we can determine the raise performances, as you can see in the figure. Now, to determine the 4-second lower performance values, we multiply the negative frequency measure by the unit deviations. This gives us both 4-second raise and lower performances. finally, we sum up the raise and lower performances over each 5-minute trading interval. This would give us raise and lower performances in each 5-minute trading interval. These raise and lower performances are later used to determine the contribution factors of the unit. In the FPP, we should also determine the performance of units that do not have appropriate 4-second metering. To do that, we calculate the performance of residual in a similar way to units with 4-second metering. In other words, in a 5-minute trading interval, we use the residual deviation and the frequency measure in each region to calculate raise and lower performance of residual in that region. You can find more information about the performance in section 6.2 of the FCFP. I hope this information has been helpful. In the following videos, we will focus on other aspects of the FPP reform. If you require more information, please visit AIMO's FPP project page or email us at fppconsultation@aimo.com.au. Thank you.